In this video, we're going to talk about changes of state. We'll look at what happens when matter changes state from solid to liquid to gas and vice versa. We're going to explain that using kinetic particle theory. Solid, liquid, and gas particles are always in constant motion. However, not all the particles are moving in the same way. Solid particles vibrate and rotate about a fixed position since they are very closely packed, whereas liquid particles, they slide over each other since they are not as tightly packed as solid. Gas particles, on the other hand, move pretty fast compared to solid and liquid. From the particles' motion, we can say that the kinetic energy of the particles for solid is very low since they only vibrate, while kinetic energy for gas particles is high since they move pretty fast in random motion. The reason the particles move the way they do is because of the attractive forces. That's the force that attracts one particle to another. The attractive forces between solid particles are very strong. That's why they are very close to one another and they have fixed shape and fixed volume. For liquid particles, the attractive forces are strong enough for the liquid to have fixed volume. However, they are not strong enough to keep the particles from sliding over one another. That's why liquids don't have fixed shape. For gas particles, the kinetic energy is greater than the attractive forces between the particles. That's why they are far apart and they move freely. In fact, there are practically no attractive forces between gas particles. That's why gas doesn't have fixed shape and fixed volume. So what happens when we heat the particles? Let's start with solid. When solid is heated, heat is absorbed by the particles and converted to kinetic energy. That means the particles will vibrate faster. As the temperature increases, the particles will move even faster and eventually overcome the attractive forces that hold the solid particles together. At this point, the substance is now liquid. If we continue to heat up the liquid, the same thing happens. Liquid particles will absorb the heat, turning heat into kinetic energy. They will move faster as the temperature increases. Eventually, they will have enough energy to overcome the attractive forces. At this point, the substance is now gas. The temperature when solid turns into liquid is called the melting point. Notice that the temperature stays the same as solid turn into liquid. Once all the solid particles change to liquid, then only the temperature will continue to rise. Boiling point is the temperature when the liquid turns into gas. It stays flat at the same temperature when liquid particles change to gas. The temperature will only increase once all the liquid particles change to gas. Now what happens when we cool down the particles? Starting with gas, when we cool the particles down, they release heat into the surrounding. As the temperature decreases, the gas particles lose energy and move more slowly. The particles become closer and the attractive forces increase. Eventually, the attractive forces is high enough for the gas to turn into liquid. If we continue to cool down the liquid, the same thing happens. The liquid particles will continue to release heat into the surrounding, move slower, and eventually become solid. The temperature when gas turns into liquid is called the condensation point, and freezing point is the temperature when liquid turns into solid. Same like the melting and boiling point, the condensation and freezing point stays at the same temperature until all the particles change their state. A little fun fact. Did you know that the temperature for boiling point is the same as condensation point? That's because these 2 points involve change of the 2 same states, which are liquid and gas state. And the same thing goes to the temperature for melting point and freezing point. They are at the same temperature. And this is because it involves changes of 2 same state, which is solid and liquid. With that, we're done explaining the changes of state using kinetic particle theory. Quick recap. We connected the motion, kinetic energy, and attractive forces in solid, liquid, and gas. Then we explained what happens to the particle when heat is applied and the particles change from solid to liquid and gas state. That gives us the heating curve. One thing we didn't talk about in heating curve is sublimation, which is the conversion from solid to gas directly. The idea is the same as when solid particles absorb heat turning into liquid. except for in sublimation, the solid particles absorb enough heat to become gas directly, without going through liquid phase. And then we look at the reverse when particles are cooled from gas to liquid to solid. That gives us the cooling curve. We also didn't address deposition where gas particles convert to solid directly. The idea is the same as gas turning into liquid, except for in deposition, gas turns into solid directly without going through the liquid phase. Lastly, the two temperatures in heating and cooling curves are the same. Boiling point is at the same temperature as condensation point. Same goes to melting point and freezing point. Here are two more videos that might interest you. Thanks for watching all the way to the end. If you find this video helpful, be sure to give it a thumbs up, share it with someone, and don't forget to subscribe. Hit that bell icon so you won't miss future uploads. Your support means a lot to me.